Wait a minute. Yeah. So, good morning, class. Today we are going to start a new chapter, that is pile foundations. Okay. So, let us go to our PPT. Whether all of you can see my PPT? Hmm?
Yes, sir.
Okay. Wait a minute. Yeah. So, this is a very important chapter. Even if you dwell more like in your PG courses, if you go for PGs and all, so this chapter will play a very important role because it will tell you first the basics about your pile foundations. Okay, so pile foundations are nothing but it's a foundation type. It is a type of deep foundation. So all of you can hear my voice, right?
Yes, sir.
Yes. Okay. So these pile foundations comes under the category of deep foundations. Okay. So when you will go for the deep foundation, if you have in the shallow region, if you have a very poor soil, uh, if you have a very poor soil in the shallow region, maybe within 2 to 3 meter, if you have a very poor soil, then you will think of about pile foundation. Okay, so if the poor soil is only for 2 to 3 meter, what you will do usually you will remove that soil and then you may replace with some good soil and compact it well, and then you can go for the shallow foundations. Okay, so provided your loads are small. Okay, so if you are building some small residential building, then that solution is good because going for the pile foundation is a very costly affair. Okay, so it requires a lot of money. Hmm? So because it is a very a specialized type of foundation, so even the contractors also even contractor also should have some good experience in the design, in the pile installations. Okay, so it require little bit cost involved in the pile foundation is little bit higher, huh, than your shallow foundations. Okay, so as far as your soil is concerned, if 2 to 3 meter, if the poor soil is there, then best solution is just remove that soil. Whatever poor soil is there for a shallow depth, you remove it and replace it with some good compacted soil. Okay, so that is the first alternative. That is just kind of a ground improvement. Okay, so you would have already studying about ground improvement. Okay, so again, in the ground improvement, many methods are there, huh? Like chemical stabilization, mechanical stabilization, or hydraulics, or by playing with the water content also you can improve the soil. Okay, so there are many methods are there. One of that method you can employ. Hmm? So always you should cost also will play a role in deciding the foundations. Hmm? Suppose if you have a lot of lateral loads, huh? So suppose see, this is a transmission tower. So this transmission tower will have a very small vertical loads. Vertical loads will be very negligible as compared to the horizontal load, because your wind load and will play a major role there here in transmission lines. Okay, so in these transmission lines, whenever your lateral loads are major than your vertical load, then you can think of for a pile foundations. Okay, so this is the one case where you can think of the pile foundation. Okay, so another case, you see, this is the a recent example in 2009, I think. Okay, so in the 2009 in China, so they built one big this residential building complex. Okay, so see, one of this structure has been collapsed. Okay, so this structure is was founded on the pile foundations. Can you see here small projections here? Huh? All these are pile foundations. Hmm? So what happened was the structure was just built. Okay, so it was just to within a week, 2 week, the people used to accommodate, used to be started dwelling in these apartments. Okay, so before opening this apartment itself, it has collapsed. The reason behind was see just in front of this I think it is a 13-story structure, 13 or 15-story structure it is. So before, just in front of that structure, they are building one more underground structure. Okay, so for like car parking, they are building some. They are doing some excavation just in front of the this structure. Okay, so whatever excavated material was there, that they were dumping on the rear side of this structure. Okay, so it was something like this. This was the excavation going on. And here you have your structure. This is your apartment building, and here the dumping was taking place. This was the dumped soil. Whatever excavated soil is there, that has been dumped here, and in between your structure is there. Okay, so what happened during rainy, during monsoon, during heavy rain? What happened? This whatever slope you have made, this slope has collapsed, and ultimately this soil has been lost, failed. Okay, so once this soil is failing, what will happen? Entire thing will collapse here. This entire thing will collapse. While collapsing, what happened? These whatever piles are there, no? These piles have been sheared off. Okay, so here these piles have been sheared due to this huge movement of soil. Okay, so due to this huge movement of soil, what happened? All these piles have been sheared. It was not a fault of the pile as such. It is mismanagement of these storing of the materials, soil materials. So this is one of the failed example you can take. Think of how the piles. See, there are different ways to. There are different phenomena under which the piles can be failing. Okay, so either it may be failing due to your excessive settlement, or due to your lateral load. Okay, so it is a case of lateral load. You see see the soil is moving. The soil is moving and exerting a lateral force on your piles. Okay, which has been sheared off here. Okay, so these are the typical examples you can see failure situations of pile foundations. Okay. So with this brief motivation, we will go for the detailed chapter. Okay, so this is your syllabus. Okay, so first we will discuss different types of piles. So there are many different ways to classify the piles. Okay, so some piles will be classified based on the material used, and some piles are classified based on the functions they carry out, and based on the applications. Okay, so there are different types, different methods to classify the piles. Okay, and then once you thorough about different availability, different piles available, then we will calculate, or we will compute how to calculate the load carrying capacity of the pile. Okay, so if you have a pile, so how much load it can take? What is the load it can take this pile? So that can be found out by two methods are there. One is the static method, and another one is the dynamic method. Okay, so those things we will discuss in this load carrying capacity of the pile. Okay, so once we finish this, then we will go for the negative skin friction. Okay, so what is skin friction? I will come to later stage. So usually what will happen when the pile is there, when you drive the pile, there are two. See, this load will be registered by two parameters. One is the end bearing of the pile, and another one is the skin friction. Okay, so this skin friction will be along the length of your pile. Okay, so what will happen usually? This skin friction will resist the applied load. Sometimes during negative skin friction, what will happen? See, 1 minute. Okay, so be careful where I am drawing these arrow marks. Okay, so usually positive skin friction means this kind. Like your loads are coming down and your friction is in the upward direction. This is positive skin friction. Okay, what will happen in the loose soil? Sometimes in the loose soil, what will happen when you will drive the pile? No, so you will produce whatever surrounding soil is there. No? This surrounding soil is settling more than your pile. In that case, what will happen? The friction will be in the downward direction. Okay? So once the friction is in the downward direction, that is called as negative skin friction. So where in what type of soil you will encounter this kind of a negative skin friction, and what are the what do you call these remedies for those negative skin friction? Okay, so how you can avoid this negative skin friction? Those things we will see in this section. Okay, so once we complete this single pile, then we'll go for the group capacity of the piles. Okay, so group capacity means see, always in the field we will not be having a single pile. We will not be having a single pile, so always you will have a combination of piles. It may be like a combination of 2 by 2 pile, or it may be a combination of 3 by 2 piles. These are the plan view. Okay, so we will have a group. Single pile will not be having. Okay, so usually in the field situation, we will not be, very rarely will go for a single pile. Okay, so obviously it is always it is better to have a group of piles rather than single pile. Okay, so again it depends on the these efficiency coefficient. Okay, so we will see in the coming lectures how we will calculate the pile group capacity. Okay, so load carrying capacity of the pile group, and then how we will compare with a single pile, and how we will calculate the efficiency of the group. Those all things we will study in this section. Okay, so efficiency of a pile group and pile group. Then in the final stage, this is the pile load test. So that means, see, whatever this with static or dynamic, we will calculate whatever load carrying capacity. Suppose this load carrying capacity of the single pile is something around 90 tons. Whether this 90 ton is really the pile is taking or not, we don't know, because whatever calculations we are doing, it is based on some analytical solutions. Okay, so in practice, actually, whether this 90 ton, whether it will take or not, we have to check. Once we cast all these piles in the field, then what will happen? We will apply certain loads on these piles. We'll take certain we'll choose certain piles, and then before constructing your superstructure, what we will do? We will apply certain loads to check whether it can take 90 tons or not. That we will check it. Okay, so those things we will cover in the pile load test. Okay, then settlement of the pile. Okay, so we will also check. We will also calculate how much allowable settlement, vertical settlement, and how much allowable lateral settlement. Okay, so those things we will see here, and also under rimmed piles. Okay, so this is the another type of concept. Under rimmed piles are nothing but see, once you have a ground here, so you have installed a pile, you will make a bulb here, like some bulb we will do inside the ground. Okay, so this what we are doing, essentially we are increasing the cross section area of your pile at the ground, in the ground. Okay, so those kinds of piles are called as under rimmed piles. Okay, so these under rimmed piles are very important, where you have these pull whatever this some swelling type of soils, if at all in the black bottom soil and all, usually we will use these under rimmed piles, where you have a high lifting pressure will be there. Okay, so this uplift pressure, if your uplift pressure is more, then usually will provide this kind of under rimmed piles. Okay, for example, the piles installed in your BC soil, that is black bottom soil. Usually in the black bottom soil, you will go for these under rimmed piles. So this is your brief content of the chapter. So before dwelling into all these content, just I want to have a big picture. Okay, so what is the big picture here? See, foundation type. Firstly, we have classified into two types. Okay, so one is the shallow foundation, and another one is the deep foundation. Okay, so in our previous class, we have studied this. Here, this thing we have already studied in the shallow foundations. Okay, so like Terzaghi's bearing capacity theory we studied, and then IS 6403 also we have studied, and how to calculate the bearing capacity of the soil, and how to check its settlement, what is allowable load bearing capacity. Everything we have studied in this section. Okay, so here today in this chapter we are going to dwell into this part. Okay, so of course this drill shaft is not in your syllabus. Okay, so in the deep foundation, again two types of deep foundations. One is that piles and a drill shaft. Drill shafts like well foundations also, sometimes we will call it as a well foundations. Okay, so those things we'll study in this category. So first, what is the motivation to study the pile foundation? If you see this picture, so these are the structures comes under your onshore structures. Okay, so these are called as onshore structures, and here it is called as your coastal structures. These are the coastal structures, and these are the offshore platforms. Okay, so offshore platform means will extract oils present inside your seabeds. Okay, so usually seabeds will have some natural gases. Okay, so those natural gases also will to collect those natural gases, we need these kinds of oil platforms. Okay, which will be under a deep sea. Okay, so you see all these kinds of structures require piles. Okay, so these section may or may not require much these pile foundations, but these two sections, you see, a lot of pile application will be there in these fields. Okay, so usually these onshore structures also will have piles, but compared to compared to the pile foundation, you have other options also. You can go for other options, but in case of your offshore structures or marine structures, always will go for the pile foundations. All these are pile foundations. So these are all pile foundations. So now you understood, no? The pile foundation application is not only restricted to your buildings. They have a wide application in your marine structures to build your wharf structures, or see, in marine structures, many structures will come, like your these jetties will come, and wharf structures will come, and even this what do you call quay walls will come, and many structures will come under these coastal structures. And of course, in the offshore structures, these to support these oil rigs, we have to install these, or whatever these legs will be there. These legs will be usually, they will rest on these pile foundations. Okay, so because these seabed will be very soft, right? This seabed, almost it look like it is almost like a butter. So in the butter, you can't expect to put your shallow foundations, right? So you have to put your pile foundations. So this is the larger picture, or you can say for motivation to study this pile foundations. Okay. Now you see one usually in the marine structures, these pile foundations will have a wide applications. You see, the pile foundations have a very wide application in ports and harbors. So because the structures, as most of the coastal deposits consists of loose or soft deposits, the loading intensity will be very high. Okay, you see the combination of both. Soil is very soft, combined with you have a very huge loads will be there. You see, can you see these big cranes? These big cranes has to manage lot of these cargo ships. Okay, so usually what will happen? These cargo ships will come and they will be docked here. So this is called as wharf structure. Okay, so this wharf structure or jetty also you can call. Okay, so if it is perpendicular to your sea, then it is called as a jetty structure. So for time being, I will use jetty and wharf. I will consider it as the same. Okay, so but it is not actually same. They are different. So usually they are platform where you will unload and load your these containers. Okay, so big container ships will come and they will be docked here. So with the help of these cranes, they will lift those containers, and or they will unload or load the containers. Okay, so to support this dock structure, we have a below this dock structure we have pile foundations. Okay, so to support these huge loads will be there, and also usually see in the water and below the water also usually see this sea will be water depth will be around 10 to 15 meter depth will be there water, and then you will reach your seabed. Again, seabed also will not be having a very good shear strength to carry these all loads. What will happen again from the seabed also you have to go for a deeper in the pile to install these pile foundations. Okay, so this is the one usually the picture of your port and harbor. Okay, so where you have a huge container ships will be there, and these containers with lot of raw material, everything it will be there. So you have to be loading and unloading. You have to do. So all these kinds of structure has to be supported, right? So these structures cannot. Anyway, this is your ship. It can float on the water, but these structures cannot float on the water. So they need a very good foundations to support all these facilities. So all these facilities will be supported on pile foundations. Okay, so just you see how many ports we have in our India. So around some 14 to 15 ports. Okay, roughly we'll have see almost from Gujarat coast to West Bengal coast. We have many these ports will be there. Okay, so all these ports, whatever the facilities available in these port structure has to be rest on the pile foundations. So can you imagine how important the pile foundations are? Huh? So almost see all the port structures has to rest in a very good strata, which has to be carried by your pile foundations. So we'll take one example. So just see whatever till now we are discussing, it is just a motivation to emphasize how important the pile foundations are. Okay, so this is the port layout, Chennai port layout here. Okay, it is having some 3 docks will be there. Okay, so this is a Dr. Ambedkar dock, and here it's a Jawaharlal dock, and this is a Bharti dock. You see, these docks are nothing but where you will park your container ships. Okay, so what will happen? This is the Bay of Bengal. From the Bay of Bengal, what will happen? These ships will come and they will take a turn, and then they will be docked here. Okay, so these all jetty structures or wharf structures has to be sitting on the pile foundations. Okay, so these all whatever structures will come in this region has to be usually 99% of the structures, whatever are facilities, whatever available here, has to be rested on pile foundations. So these pile foundations have a very wide applications, not only in the civil, even in your onshore structures, even your offshore structures, or even your marine structures. Everywhere you have these applications of pile foundations. Okay, so with that motivation, now we'll go to why. First of all, why we need a pile foundations. There are different reasons under which we will go for the pile foundations. First reason is if surface soil is too weak to support the foundation loads. That is your strength criteria. And if the surface soil is undergoing a lot of settlement under the applied load, then also we will go for the pile foundations. That is your deformation criteria. That is serviceability criteria. Okay, so this is your serviceability criteria. Then what is the third reason? If you are constructing over water, like your port structures. Okay, so just now whatever I shown now, if you are constructing over water, then also we'll go for the pile foundation. So best example is your berthing structure or wharf structure. Okay, so these wharf structure where you will unload and reload your these containers. Then if you are resisting any uplift force, suppose if you have a you see this is a transmission tower. When you have a wind load, what will happen? This pile will be under a tension. So this pile will be under tension where you have a possibility of uplifting. Okay, so in those circumstances also we will go for the pile foundation. So and then what is the fourth circumstance where you have to resist the horizontal loads. Okay, so suppose this is the sheet pile wall. Okay, so this sheet pile wall will have a lot of horizontal stresses from this soil. Okay, so to resist this sheet pile wall, this is just like a horizontal loading. Okay, so you want to resist some portion will be resisted by this sheet pile, and some portion of the load will be taken care by these anchors. Okay, so here also we have a lot of these horizontal loads will be there. Okay, so to resist those horizontal loads also we need a sheet pile walls. And if see another circumstances where we need these piling is to avoid any score damage. What do you mean by score damage? See, usually in the bridge piers. Okay, so suppose this is a river flowing. This is the river flowing. So you have to build a bridges here. Okay, so to build a bridge, what will happen if you go for shallow foundation? What will happen? See, always over the years, what will happen? This river it will erode the material, and then if you have a shallow foundation here, whatever soil material is there below, it will be eroded. Once it is eroded, your bridge pile will be hanging. It will be hanging in the air. What will happen? Easily it will be collapsed. So to avoid that, what will happen? We will usually go for these pile foundations. where you have a chance of scoring. So these are the different situations where we will prefer to have a pile foundations. So first of all, what do you mean by deep foundation? Anyway, I already know the definition of the shallow foundations. Just reverse of that will be your definition for deep foundation. What is that? If your depth of a foundation is greater than the breadth of the foundation, then those kinds of those kinds of foundations are called as deep foundations. Okay. So what do you mean by depth of foundation? It is usually the length of pile. What is the width of foundation? It is usually your diameter of the pile. Okay. So if your width of foundation is smaller than your depth of foundation. This is my depth of foundation. This is my width of foundation. Okay, so if it is very small, then we will go for the we will call them as a pile foundations. Okay, so if deep foundations, usually what is the definition of the deep foundation? If your depth of foundation is greater than your diameter of the pile, then our diameter of the our width of the foundation, then we will call those foundations as a deep foundations. So what are these applications? Applications are like to carry large column loads where shallow foundations are inadequate, and to carry column loads when the ground condition is poor. There also we will go for the pile foundation. And also if you are having if you have to carry a lateral load, then also we will go for the pile foundation to resist uplift loads and to improve the existing foundations. Those are called underpinning. Okay, underpinning means you already existing structure is there. Okay, suppose you have some two-story building. Some two-story building is there. Now after some years, what happened? You realize that I want to go for some more three more floors. I want to build 3 more floors here, or 2 more floors I want to build. Okay, then you for under that load, this whatever foundation you employed already, it is not sufficient to carry that load. Okay, so in that case, you have to improve this foundation before going for these extended floors. Okay, so in that case we have to improve these piles. Okay, so what will happen? Usually people will go for this underpinning. You will insert some kinds of piles below these existing foundations. Okay, so those are called as underpinning. So in that that is also one of the application of your pile foundation. Suppose these are the different applications of the pile foundations. Okay, so these transmission tower and these anchor sheet piles and your under-reamed piles. Okay, so under-reamed piles usually will go for this in the expansive soil. Whenever you have expansive soil, we will go for these under-reamed piles. These are the different applications of the pile foundations. So again, these are just repeated in we are just I put in terms of some bullet points. Okay, so these are part of these already I explained. Okay, so where you need all these pile foundations, where you have a weak soil layers at the top, and where you have a rock level at the deeper depth where your loads. Okay, so these are the when you have these when you have rocks at a deeper depth, and if you go and your loads are very heavy, there also will go for the pile foundation. Then if you have a huge lateral loads also, then also we'll go for the pile foundation. Okay, so in presence of expansive soil also, we'll usually resort to your pile foundation. And almost all offshore structures will be built on pile foundations. Okay, so and if you have a strong uplift force also, you will go for the pile foundation. For structures near flowing water, like what I explained, like bridges and abutments, there also we will have a pile foundation to avoid any problems due to erosion. So this is part of this point only, I think. Okay. Okay, now actual syllabus will start here. Okay, so whatever till now we discussed, that is just to motivate you how important this chapter is. Okay, so actual syllabus will start from here. Hmm? Classification of piles, like your the possibility, like exam from till now whatever you discussed, those are just to give a brief broader picture of pile foundations. Okay, so now onwards your exam questions you can expect. Hmm? Like a classification of piles. First, how you will classify? There are 5 types of classification. You see, first based on classification based on method of installation. Okay, so that method of installation means how you will install the piles. Okay, so that is the method of installation. And second part, the second type of classification is based on the load transfer mechanism. Okay, so how the load is transferred. This is the second type of classification. Okay, and third type of classification is based on the material itself. Okay, so what type of material is used in the piles, so whether you are using a timber or whether you are using a steel or whether you are using a concrete, depending on the material you will classify the piles. Then the fourth classification is it is based on the displacement of soil. Okay, so while driving or while installing the pile, how much you are disturbing the adjacent soil. Okay, so like based on that you will classify displacement, low displacement, non-displacement. These are the different classification based on the displacement of soil surrounding the soil while installing the pile. Okay, so the fifth classification is based on the function. Okay, so what function they are doing, whether they are doing a load bearing piles or compaction pile, a tension pile, sheet pile, fender pile, anchor piles. These are based on the function of the piles. Okay, so these are the 5 types of classification. Okay, so first we'll see, in detail we'll see the classification based on method of installation. Okay, so these are the types of piles based on the method of installation. Okay, so these are 5 types of piles which are being classified based on a method based on that type of installation. So first category is the driven piles. So driven piles is nothing but you just hit the pile inside the ground. It's just some cartoon. Actually, you will not install the pile like this. In the later stage, I will show how we will install the pile, but it is a close resemblance of installation of pile in the, as far as the driven piles are concerned. And then second type of pile installation is driven and cast in place pile. Okay, so what do you mean by driven and cast in place? First, we'll drive some casing pipe. Inside the casing pipe, we will cast the pipe. Okay, those are called as driven and cast in place piles. Okay, so in the coming slides, I will show pictorially how these piles have been will be installed in the ground. Okay, so and third type of installation is the jacker piles. Okay, so jacker piles are nothing but they will be either it may be a steel or concrete units which will be installed in the ground with the help of these hydraulic jack. Okay, and then fourth type of piles will be screwed piles. Okay, so these piles are screwed into the soil. How you will screw your nail inside the wood? No, in the similar fashion, these screwed piles will be installed, but the application is specific to only certain regions. Okay, so which are not widely used at all. And the fifth type of installation is bored and cast in place. Okay, so this is very important type of piles as far as our civil engineering is concerned. Okay, so where these almost 90% of our piles which will be used for building purpose or for the construction to support our superstructures, we will usually have this bored and cast in place piles. Bored cast in place is nothing but first we'll make a borehole or boring will be done. In that boring, we'll install these reinforcement, and then after reinforcement, then we'll plug this, we'll fill this hole with the concrete. Okay, those are called bored cast in place piles. So in detail, we will see what are these driven piles and all these. Okay, so just pictorially, I will explain here. So driven piles are usually these driven piles will be they may be either steel pipes or it may be a precast concrete piles. Okay, so these are the precast concrete pile and these are the these steel pipes. Okay, so usually these will be used in the marine structures. Okay, so marine and offshore structures. Okay, so in the offshore structures to support, in the offshore structures, so what will happen? This driving these piles is not that much problem because the soil will be very soft. In that soft soil, the drivability of these piles will be easier. Okay, and also if you go for installation, also much cheaper than your cast in situ piles in case of your these marine structures and offshore structures. So you see, can you see here markings? Some markings are there. You see, -65, -66, -67, -68. Okay, so these are the markings which will be marked. And see, here is some these driving some hydraulic jack kind of thing will be there, that which will drive this pile inside the ground or inside the sea. You can if you are building offshore structure, then it is inside sea. If you are building some jetty structure, then it will be like, it is also inside the sea, but it is very close to the beach. And even in some, if the soil is very soft, even you can use these kinds of soil, these kinds of piles in your onshore structures also to support your conventional buildings. So then this is the driven cast in place piles. Okay, so that is your second type of category. Okay, so this is the driven cast in place piles. Okay, so what do you mean by that? First, you will drive the pipe, steel pipe inside the ground. Driving will be done. Then we will insert the casing. Reinforcement cage will be installed. After the reinforcement cage, then we will put the concrete. After putting concrete, usually what will happen? These pipes will be extracted from this casted pipe. Okay, that's why it's called as driven and cast in place. Okay, so you are driving the pipe, you are driving the casing pipe, and you are casting the pile inside the place. Okay, so cast in place means what? Casting at the place itself, at that place itself. Okay, so we are casting the pile in the ground itself. That is called as cast in place. Then why the name driven is coming? Because we are driving the casing pipe here. This is the casing pipe, we are driving it. Okay, that's why the name comes driven cast in place piles. Then jacker piles. Okay, so that is the third type of installing the pile. Okay, so see, this is the platform. Okay, this is the jacking platform where we will insert the pile. Okay, so this is the closer look. So what is happening inside here is shown here. So inside a pile, this is the pile. So where you have a jacking platform, with the help of that jacking system, we are pushing this pile inside the ground. These are called as jacker piles. Then your final type, what is the number here? I think that we discussed. Exclude anyway. I have not put any photo for this. And then these board cast in place piles. Okay, so now you see board cast in place, how it look like. So this is the board cast in place. So this board cast in place is nothing but, first what we will do, we will casing pipe will be driven, and then to support the borehole. Okay, so what will happen once we support the borehole, then we will see, with the help of these agars, we'll drill out, we'll take out all the soil material inside. Okay, we'll take out the see here, all the soil has been taken out, took out. So once we took out the soil, then you insert the cage, your reinforcement cage you insert, and then see, this is called as trummy pipe. With the help of this trummy pipe, we will put the concrete inside the this hole. Once you put the pipe, then you can once you put this concrete, then you can pull off your casing pipe. This is the board cast in place pipes. So this is different stages of this this whatever picture I have shown now. This actual with some filled photos I want to show you. See, this is the your baler type of what do you call, to remove the soil, or you have a helical type also. Either you can have this type or this type. What we'll do, we'll rotate it inside, and we will make a hole like this inside the ground. We'll take out all the soil present, and then we will make a hole like this. So this is under process. So once we have a hole, we will install the reinforcement. We will install the reinforcement, and then with the help of trummy pipe, we will fill this hole with the concrete. Once you fill, then you will get a pile like this. Okay, you see, this is the pile. Then from this pile, you whatever your columns will start. Your superstructure column will start from here. Then you can proceed your superstructure. Okay, so you see, this is another pile. This is another pile here. So these are the board cast in situ piles. Okay, so these are the major type of piles which will be used in India. Okay, so almost 98% of piles which are being employed for to support your conventional buildings. Usually these board cast in place piles will use. Okay. Then classification based on this is second type of classification. Okay, so what is the second type of classification? It is based on load transfer mechanism, how the load is transferred. Okay, so this is the load. Sorry, somebody, any doubts are there?
Sir, explain jacked again, sir.
Jack piling you are asking.
Yes, sir.
This jack, you see in the plate load test, have you observed there also we have used a jack system, right? That same mechanism will be employed here also. In the plate load test, what we have done, we have put a plate here. We have put a plate here, and then we have put a jack here, and here some cantlage was there. Some dead load we have put, and then what will happen? For this jack, we will pump the oil inside this jack system. Okay, once we pump the oil, then what will happen? It will try to lift your whatever dead load is there here. Dead weight is there. No, here. See, this will play like a dead weight. So with the help of that dead weight, in turn it will push the plate inside the ground, right? It will push this plate inside the ground by taking reaction from this dead load. The same concept is here. Okay, just instead of plate, we are having a pile. But instead of having small cantlage, we have a very big cantlage. You see, very big cantlage. But these kinds of piles are very rare, especially as far as India is concerned, because in India we don't have this kind of technology to push these piles inside the ground. Mostly these will be used in these offshore structures where you have these berthing structures will be there. There we will go for these kinds of piling. Okay, so but in conventional civil engineering structures are to carry conventional to support conventional buildings, usually we won't go for these kinds of jacked piles. Usually these jacked piles have a very specific application in a specific field. Understood? Shall I move forward? So this is a very important type of pile. Okay, so because often we will encounter these kinds of pile in our practice. Usually, mostly in the Indian context. Okay, now coming to till now what we have seen the classification based on the method of installation. Okay, so whether you are driving the pile or whether you are driven pile, driven cast in situ pile, or jacked pile, or screwed pile, or cast in place these piles. These are all based on how you are installing the pile. Okay, so now we will see the classification based on the load transfer mechanism. Okay, how the piles are transferring the load. No, based on that also we can classify the pile. So first type of pile based on the load transfer mechanism is end bearing pile. What do you mean by end bearing pile? The end bearing pile is nothing but, so this is the pile and this is the load coming from your superstructure. Okay, so from superstructure whatever load is coming, no, this load entirely taken care by your end bearing. Entirely taken care by end bearing. Then those kinds of piles are called as end bearing pile. Okay, so whatever this load is, this load is resisted by only at the pile tip. it is just like your shallow foundation except the length. Okay. Then second type of pile is your frictional piles. So before going to frictional piles, just I want to tell you, see, this usually these end bearing piles are usually will be employed where you have a hard rock at a shallow region. Within 10 to 20 meter, if your hard rock is there, then these kinds of end bearing piles will be useful. Okay. Suppose hard rock is not at all at the scene. That means your hard rock is you are encountering at 30, 40, 50 meter at a 50 meter depth. Then you have to rely on this frictional resistance. Okay, so whatever this load is there, no, this load is resisted by only the frictional this whatever this is called as skin friction. Okay, so from the friction between pile and soil, between them whatever frictional resistance will develop, no. So if the entire load, your Q load is taken care by frictional resistance, then those kinds of piles are called as frictional piles. So these frictional piles usually will employ where we have what I told, no, just the hard rock is much deeper level, like more than 50-60 meter depth. If a hard rock is more than 50-60 meter, then usually will these kinds of piles will be used. Those are called as frictional piles. Okay. So then third type is combined. Okay, so you have a frictional resistance, you have a frictional resistance as well as the end bearing. Those kinds of piles are called as hard combined piles. Okay, so this Q is there, no. This Q is carried by part of this Q is carried by your these frictional force, and part of this Q is carried by your end bearing. So this Q is shared by two people who are sharing here the frictional resistance and your hard this end bearing. Those kinds of piles are called as combined piles. Understood the basic difference between end bearing pile, friction pile, and combined pile. So end bearing pile is entire Q is taken care by your end bearing. Frictional pile is nothing but entire Q is taken care by your frictional resistance. And your combined piles are nothing but this Q is shared among this frictional resistance and your end bearing. Okay. Any doubts here? Any doubts here? Okay. So once we finish this classification based on load transfer mechanism, then we will see the classification based on the material. Okay, so that what type of material you are using, whether you are using a concrete as a material, or whether you are using a steel as a material, or whether you are using a timber as a material for the pile foundation. Okay, so first we will see the concrete piles. Okay, so this concrete is used both in prefabricated and reinforced manner. Okay, so these are the prefabricated piles. So these are prefabricated piles. Mostly will be used in your offshore structures or marine structures. Okay, so in our onshore structures we will use these kinds of cast in situ piles. Okay, so this is the concrete pile which has been casted in the ground itself. Okay, that's why it's called as cast in situ piles. So they have a very large load carrying capacity. You see how much it can carry, around almost 7,000 kilonewton they can carry, these concrete piles. The prefabricated piles are manufactured in plants and transported to the job site and generally installed by driving or jetting. Okay, so by driving means we will have some vibratory kind of hammers will be there on the top. With that vibratory kind of hammer, we will drive these piles inside the ground. Okay, and then these cast in place piles are installed by first creating a void in the soil and then filling it with the concrete. These are cast in situ piles. These are the driven piles. These are the cast in situ piles. Again, in the concrete piles, I'm talking these all categories. The compressive strength of concrete ranges from 25 megapascal to 40 megapascal. For your precast concrete. Okay. So usually these precast concrete, the strength of your concrete used will be of 25 to 40 megapascal. and from 11 to 25 megapascal for cast in situ piles. Okay, so if you are using a cast in situ piles, then the strength of your concrete should be 11 to 25 megapascal. Okay, so these are the concrete piles, and again in the concrete pile, see, I think I am not shown about another two types like steel piles and your timber piles. Okay, usually the timber piles will be used for the temporary structures. Okay, so if you have some even your olden, usually those timbers are used in the olden structures. Okay, so for example, if I want to tell these in Italy, one city is there. No? What is that? I forgot its name. That entire city is built on these wooden piles. Hmm? Venice. Have you heard this Venice city in Italy? So in the Italy, this Venice city is Venice is a small island in Italy. It's in the middle of the this little off coast of Italy coast, and there this entire city is on these kinds of wooden piles. Okay, so these they driven these wooden piles, and they are over that wooden piles they built a city, entire city they built. Okay, so usually those wooden piles will have a very small load carrying capacity, and also they are temporary, because usually what will happen under these water, these wooden piles may they may disintegrate. Sorry. See, usually these wooden piles they will undergo this disintegration under the water. And even steel piles also. Anyway, steel piles also we already discussed. Within the steel piles will be usually will use in these offshore structures. Okay. So now another type of classification is based on the displacement of the soil. The classification based on displacement of soil. So how you, based on the soil, how you are how much disturbance you are causing to the surrounding soil while installing these piles. Based on that also we will classify the piles. One is first type of classification is based on like non-displacement piles. Okay, so non-displacement means you are essentially we are causing very little disturbance to the surrounding soil while installing the piles. Okay, and then the second type is called second type of these piles are high displacement piles. High displacement means see, lot of soil material you have to excavate. A lot of soil material you have to excavate, as well as you are while excavating you are disturbing you are causing a lot of disturbance to the surrounding soil. Those are also called as high displacement piles. And then another type is called as low displacement. Okay, so you are causing some disturbance, but it's not as high as your high displacement piles. Okay, so those are called as low displacement piles. So again, here are some examples for non-displacement, high displacement, and low displacement piles. So high displacement means, you see, while you are driving a pile, no, these are the concrete piles. So to drive these piles, a lot of disturbance will be created. So that's why these concrete piles are driven piles are classified as a high displacement piles. Usually these driven piles will be classified as high displacement piles. And low displacement piles, when you call a low displacement piles, so high displacement piles are driven piles in soft sensitive clay, which are more common deposit along the coast, makes clay around the pile into remolded clay. Okay, so the strength of such remolded zones is much low compared to that of the natural strata. In such situation, where driven piles are wherever your driven piles are unavoidable, then low displacement piles like your H piles, H piles or open-ended piles or screw piles will be used. These are the some examples of the low displacement piles like your H piles, open drive piles, where you are we are causing very small displacement or small disturbance to the surrounding soil. Okay. So now the classification based on the functions. So first the based on function, if you want to classify, first function is the load bearing piles, like your whatever your vertical loads are there, no? Those vertical piles are taken care by your end bearing as well as your frictional resistance. Okay, so those are called load bearing pile. And then compaction pile. The compaction pile is nothing but see, while driving the pile, what will happen? A lot of disturbance will create. Okay, so due to that disturbance, what will happen? The surrounding soil, whatever soil is here, that will be compacted due to that vibration. Okay, see here also the soil is compacted while driving this pile due to the vibration generated while driving this pile. So those kinds of piles are called as compaction piles. Then tension piles, where you are registering your tension. Those are those kinds of piles are called as tension piles. Then sheet piles. Okay, so sheet piles again. These sheet piles will be used wherever, if you suppose if you want to have a very dry working area, where you have if you are in the middle of the river, or if you are in the middle of the sea, where you suppose if you want to construct some structure there. Okay, so before construction, what do you need? You need some dry place here to work around. So to avoid to get this dry place, you will use this sheet pile walls. These are called as sheet pile walls. Okay, so the sheet pile wall will give you this dry area where you can work and you can do whatever construction you want to do in the middle of the sea or in the middle of the river. Those kinds of piles are called as sheet piles. Then fender piles. Okay, so these fender piles are nothing but you see these usually these rubber kinds of piles will be there, where see these wherever you docking, this is the docking structure. Okay, so like jetty or maybe some wharf structure. Okay, so what will happen? Your container ships will come and they will be parked here. So your crane will be there. Here from the crane they will unload or reload the container. Okay, so if you see, usually these ships will not have any brake system. Okay, so you can't see so you can't apply any brakes there. Okay, so what will happen? Sometime this sea will be it will have these waves will come. Okay, so high tidal waves, low tidal waves. Under that tidal waves, what will happen? These ships usually will hit these your permanent structures, wharf structure. Okay, so if you don't have this fender pile, what will happen? This ship will hit your these jetties. Okay, so where you will damage your jetty, or you may damage your container ship also. Okay, to avoid that, we'll use this fender piles. Okay, so these fender piles, what will happen? They will absorb the whatever these friction will this frictional force will come into picture because of this high tide or low tide. Those will be absorbed while parking these containers. So those will be absorbed by these fender piles. Okay, just to avoid any damage to your jetties or any damage to your containers. Okay, so these are called as fender piles. So then another type of piles are called as anchor piles. Okay, so these anchor piles are nothing but wherever you have a retaining wall. No, so in the retaining wall so these retaining wall will be under horizontal loads. Okay, so this soil, whatever this soil is, this soil is trying to push this retaining walls. Okay, so that load will be carried by part of that load will be carried by the bending stability or bending strength or bending stiffness of this retaining wall, and part of that load will be carried by your these anchor piles. These are called as anchor piles. Okay, so this is the classification based on the function. Okay, so here I will stop it here. Okay, so anyway I explained, just I put it in word here. Okay, so here I have shown in the picture and as well as I written here what are the different types of piles based on the function. So I will stop it here. So in the next class, what I will do, I will start to calculate the load carrying capacity. Okay, so what we discussed till now is, if you refer your pile syllabus here, so this thing we discussed till now, that is types and classification of the piles. This part we discussed. Okay, so in the tomorrow's class, what I will do, I will calculate the load carrying capacity of the pile based on the static method and dynamic method. Okay, so first we will start with static method, and then Maybe static method I may take some 3 to 4 hours, including problem. So again, dynamic method some 2 to 3 hours I may require. And then negative skin friction is just half an hour job. Then these okay, we'll see how the for this little bit. I want to spend more time because the application of these piles are more here in the real life. When once you start your practice, there you will once you graduate and join some companies, so where you will start designing piles. So applications of these piles will be very huge. So I want to spend more time on this chapter. So allotted time is 10 hour, but I don't think 10 hour is sufficient for this chapter. Okay. So if I want to summarize whatever things we have discussed in today's class, so first we began with the motivation. Okay, so what is the big picture? The big picture is this one. Okay, so the application of piles is not only restricted to your onshore structures. The piles can be piles have a wide application, whether offshore structures or marine structures or onshore structures. Wherever you go, the piles will be used. Okay, so once we know the importance of pile, then what we did, we classify the pile. Okay, so again, classification depending on the different yardstick. Okay, like first yardstick was based how you are installing the pile. Okay, and then second yardstick was what is the type of material used in the pile, whether timber, concrete, or steel. Then load carrying mechanism, whether end bearing or frictional bearing or combined bearing. Okay, so and then we have seen based on the these applications like anchor pile or fender piles or your these batter piles. Okay, so those are all under application criteria. Then we have seen based on the disturbance you are causing to the surrounding side, whether non-displacement piles or low displacement piles or high displacement piles. Okay, so these are all classification based on the different yardsticks. So I will stop it here. If you have any doubt, you can ask me based on today's lecture. If you have any clarification you require. Yes, Sandeep Bakor, are you there, Sandeep? Oh, any clarification you require? Okay. So what I will stop the recording here. So stop recording.
Yes, sir.
Yeah, tell me.
Yes, sir. You can stop.
Okay.